4. And then we want to find the rate of change of the population. We had this function before, we looked at it before together, and then evaluated when t is 10. So how do I do that?
Would you plug in
Absolutely, you're right.
would you plug in 7 to
Exactly,
t?
exactly. That's all I need to do. So we're going to do that with a calculator after we find this. When we're asked to find the rate of change, thank you so much. When we are asked to find the rate of change, what am I asked to do to this function?
Find the derivative.
Yes, p prime of t. Can anyone help with the derivative? Anyone remembers how to differentiate this?
It would be negative 0.0512 times 17 to 50 e and then to the same power.
Yes, indeed. So I'm going to multiply these two. So 0.0512 times 17250. I got, of course, negative 883.2 e to negative 0.0512 t. This is the rate of change, which means the function, which means the derivative. Thank you so much. Awesome. Now, what will I have to find if I'm asked to evaluate it when t equals 10? What do I need to do?
We just have to plug into t at 10.
Yes, in which function?
P prime
Exactly, of 10. Good. Whatever
And
number I get, it's going to be negative. What is the measurement unit? You can say you never told us. Okay, so this is people, and this is years.
people per year.
Exactly. People, because the function is measured in number of people, and t is in the denominator, so this is per year. Perfect. Now let's put the function in and its derivative, and that's it. That's all I need to do. So in y equals, clear, clear. Let's put the function first. 17. What's happening here? Okay, 17250 e to power negative 0.0512 t, close, and now the derivative, negative 883.2, of course, again, e to negative 0.0512 t, and close. So now I go back to second and table, and I need 7, and then I need 10. So 7 I copy from the function, and I have p of 7 equals 12054 people. And from the other one, I copy negative 529.3 people per year. And that's it. That's all I needed. Moving on to 25 on 314. Any questions? Don't let me move on if you have questions. Where is my book? Okay. We won 314. I'm on page 7. And I selected 25. 25, it's asking us to find the absolute max and minimum values of each function over the indicated interval. Okay, so let's take a look. 25, 1, 3, 14, and we have f of x equals natural log x to the third minus 3x plus 4, and the interval negative 3/2, 3/2. Good. So what do we need to do? We're asked to find the absolute max min on that closed interval. So here's the interval. What do I need to do? Every time I'm asked to find max min, what is your thought?
First find the derivative and then set it equal to 0 or undefined.
Excellent. We have to find the derivative and then critical numbers, and then we'll take it from there. Awesome. So can anyone differentiate this log function for us? Anyone?
3x.
Careful, careful, 1 second, 1 second. So when we have the natural log of a function prime, how do we differentiate this? What is the formula for natural log of a function? Anyone?
I can't remember.
So it's 1 over the function times the function prime. All these formulas are extremely crucial for any test and the final, right? Good, so let's come back. How do we differentiate this then?
Will it be 1 over x cubed plus 3x plus minus 3x plus 4 and then times 3x squared minus 3?
Excellent. Good, so now we have to set this equal to 0, or we have to set this equal to undefined. So for undefined, it would mean that the denominator is 0. For 0, this will mean that 3x squared equals 3, minus 3 equals 0. From here, we have immediately two solutions. Can anyone give us those two solutions for this equation after you divide both sides by 3?
1 or negative 1?
That's it. So this is f prime of x. This is f of x. We put negative 1 here and 1 here. We have to check this. No stone can be left unturned. So we have to check that. Here it is. I go back to the apps. Go to 9. It's quadratic. Yes. Yes. Okay, the first coefficient. I'm sorry, it's not quadratic. Sorry. Can how do I go back? How do I go back? I don't know how to go back, so I'm gonna just go forward. It's cubic. Good. So the first coefficient is 1, so that's okay. The second coefficient is missing, so it has to be 0. The third coefficient is negative 3. And the last coefficient is 4. Let's see if we get any real solutions. So we did negative 2.2 roughly. So x equals negative 2.2. It does not have other real solutions. However, notice what happens here. This is not in the interval. So this is negative 1.5, and we found a solution that is here to the left. So it's not in the interval. So we don't even have to talk about it. Now we need a sign of the function. Also, we need to find these values. for the function. We study the sign of the derivative, but we have to find this value under -3/2, this value under -1, this value, and this value. So let's start with the sign of the derivative. I am going to plug this derivative in the graphing calculator. So exit and exit. Here it is. Clear and clear. And go back to y equals. And I have the derivative first. So don't forget parentheses. 3x squared minus 3 divided by, also parentheses, x cubed minus 3x plus 4. And close. So all I have to do now is plug in -1.2 to see the sign. I want to plug in 0 to see the sign. And I want to plug in 1.1 to see the sign. I don't care for the number. So the sign is positive, negative, positive. So positive, negative, positive. So by putting this function in the graphing calculator and finding a number here, a number here, and a number here, I determine the sign of the derivative. Now in the function, I have to plug in exactly -1.5, -1, 1, and 1.5 to see what happens. So I go back in y equals. Now I enter the function, and the function is natural log, and in parentheses, it has x to the third, and then minus 3x, and then plus 4. And now second and table, and I want -1.5, I want -1, I want 1, and I want 1.5. I need these numbers, and the function was the second one. So 1.6, then 1.8, then 0.7, and finally 1.1. So now, remember, we have to make sure that these two work well together so we don't have an error. Okay, so let's check. From 1.6 to 1.8, what does the function do? Is that support? Yes. Is that supported by the sign of the first derivative?
Yes.
Perfect. From 1.8 to 0.7, what does the function do? And is that supported by the sign of the derivative?
Yeah.
Perfect. And lastly, here from 0.7 to 1.1, what does the function do? And if that's supported by the sign of the derivative?
Yeah, it increases.
Perfect. Now we have to decide. Okay, so here's 1.6. It goes up to 1.8. It comes down to 0.7 and goes up to 1.1. So I'm not graphing the function. I'm just presenting these values so we realize what's happening here. So what is this point? Is it a relative max or min? No relative at the end point. So this is nothing. No relative at the end point. What is this one?
A relative max.
Yes, an absolute. Absolute and relative max. Absolute, the largest, and also relative because the function exists both sides. Good. Excellent. What is this?
Absolute minimum.
Absolute minimum and also relative. because the function exists. Perfect. What does this one represent? Same thing.
Nothing.
Nothing. Nothing. It's not the absolute max, it's not the absolute min, and it cannot be relative because it's at the endpoint. Awesome. Good, moving on. 26 on 329. Page 8. 26, 329. 26. 26. Okay, so it's the same maximizing. I think we can skip this one because we have it in our notes. It's the same thing, very similar to what we covered. The same thing, find the max min of the profit. Is that okay if we skip this one?
Yes.
Okay, because I would like to get to as many as possible. 29 on 342. 342. Oops, I meant this. Yes, we have to do this one. We said 29, 29. I'm sure we did this problem in class. Maybe, I think I assigned 28 and we did 29 in class. You tell me what you want to do. 28, 29, 30. You choose. I just would like to go over a problem like that. Which one?
29.
Okay, 29, fine. Good. So 29 on 342. Good. So we have r of x, 0.005 x cubed plus 0.01 x squared plus 0.5 x. So they are manufacturing 70 units, whatever that is. What is the current daily revenue? Part A. Part B. What is the marginal revenue when 70 chairs are sold? Okay. So we're asked to find the revenue for 70. What do we need to do first?
Plug 70 into RX.
Right. We need this for later, so I have to do it now. Let's also determine the marginal, so we can put both of them. So the marginal revenue for 70 is determined how? What do I need to find first? Marginal, yes. So very good. R prime, 0.015 x squared plus 0.02 x plus 0.5. Perfect. So then the marginal revenue for 70 will be R prime of 70. Remember, these two have two measurement units. The revenue for 70 will be what measure? What will have what measurement unit?
Just dollars.
Good. But the revenue for marginal revenue for 70 will have two measurement units.
Dollars per
unit. Very good. Awesome.
pretty
Perfect. Awesome. Okay, so I'm going to punch in both functions. So in y equals, clear, clear. So the function first, 0.005 x cubed and plus 0.01 x squared. I swallowed the 1. Okay. And then a plus 0.5x. Now the derivative, 0.015 x squared, and then plus 0.02 x and then plus 0.5. And now we want, for both, we want 70. That's why I wanted to wait so I have both answers at the same time. So this is 1799 in dollars, and the other one is 75.4. Of course, in dollars per unit. Okay, perfect. So let's see where my book is here. Okay. How much will the revenue increase if 73 units are sold? That's good enough. We don't have to do 71 and 72 and 73. We did this problem in class. We have it in the notes explained again. So, okay. So we want just to find out the increase in revenue when x equals 73. And remember, this is that base important formula. F of x plus a little bit is approximately f of x plus f prime of x dx, where f prime, of course, is r prime, where dx will be identified in a moment, and f of x is r of x. So let's identify x, and let's identify dx. We are talking about 73. So this has to be 73. And this has to be tiny.
Is it 72 and 1?
Careful, because we have 70, we will say x equals 70 and then 3. Only because we already started with 70. We cannot use 71 because we don't know anything about 71. So we know 70. Is that clear?
Yes.
So then r of 73 will be approximately, so x is 70 and 70, and then here 3. So r of 70, we have it, 1799, plus r prime of 70, we have it, 75.4, and times 3. This is the actual increase, I mean the approximation, the increase. Okay? That's all we needed to do, and just calculate this, and that's the increase. And if we're asked to find all this, then we're just going to add these two. Let me do it, since, again, as I said, we worked on this problem before. So I just want to put it in so we don't leave it like that. 75.4 times 3. Oh, I multiplied instead of added. Good. So 2025.2. So this is not the actual, but this is the approximated. This.